Perhaps fittingly, this next session is titled A Dialogue About How Smart Manufacturing Technologies Enable Business Value. And I'm honored to be joined by Doug Lawson here from ThinkIQ to have a bit of a conversation on this important topic. Doug, why don't you introduce yourself and take a few minutes to talk about ThinkIQ as well?
Thank you, John. And John, thank you for the opportunity to have this conversation with you. Great conference so far. Really looking forward to this conversation. So, John, I'm CEO of ThinkIQ, and ThinkIQ is a software company with a very single-minded focus. We're trying to help industrial companies, manufacturing companies, transform their businesses to become smarter and more effective as to what they make. We think there's a huge opportunity in this area. We've been seeing the challenges that manufacturers have today with supply chain challenges. We're seeing the challenges that manufacturing as a sector has in terms of its impact on the environment and global sustainability. And certainly there's enormous economic opportunity to run physical manufacturing facilities, warehousing, and entire supply chains far more effectively than we do today. So, there's a lot of buzz around smart manufacturing, the Internet of Things, digital transformation. We at ThinkIQ believe that three things are necessary. The first is that we have to reduce complexity and democratize the ability to actually do those things. And that's at the essence of our very close partnership with CESMII, who private labels portions of the ThinkIQ platform as part of the Smart Manufacturing Innovation Platform. And we see that democratization as tremendously important. Openness is critically important, and reduction of complexity is critically important for being able to really achieve smart manufacturing. And ThinkIQ's mission is to help facilitate all of those things.
Outstanding, Doug. I've known you for a long time, and I know this isn't your first rodeo, your first manufacturing software company that you started up. Give us a bit of a sense of your prior ventures in this space. I think they form an important backdrop for the work that we're doing now together with you and other great technology providers and members here at CESMII.
Wow. Okay. John, I was incredibly fortunate in my career. I originally came from nuclear power. And I was intimately involved in building the first post-3 Mile Island accident response systems to really automate the process of intelligent decision-making by machines to help operators deal with conditions that became out of normal. So it was some of the earliest attempts for us to take the data coming from sensors and use it for things other than what it was intended as originally, which was automation purposes. And as a relatively young individual, having been involved in that, I decided that there was an entrepreneurial opportunity. So I started my first software company. We created a product that's been very successful in the market, Wonderware Industrial SQL Server, or now as it's known as the Aviva Historian, a product really designed to collect time series data from sensors and make it easily available. I then went on and created DataWorks. The product was Actifactory. And then in QED, the product was in QED EMI. And after selling that to Rockwell Automation, which is where I think you and I first began to engage, that product became Vantage Point. So I'm in a very fortunate position that between those three products, they're in use in well over 1 million different manufacturing facilities globally. And it's rare for me today to walk into a facility where at least one of those three, if not all of those three products, are in use by customers. So at least leads to fun conversations at the beginning of the meeting.
Yeah, Doug, I think what that tells me, if I'm getting the math right here, is that what you're working on today with ThinkIQ and part of the work that we're doing together with you is essentially a third generation data contextualization capability. Is that fair?
I think that is. If the biggest learning experience that I think we've had over that period of time is the critical importance of data contextualization and the data model.
So let's dive right into kind of the first question or the first issue, I think, that you've just alluded to. Data contextualization, I think, is well understood at a 30,000 foot level by most. I think the famous Jim Wetzel said 3 or 4 years ago that connectivity is important, but it's not sufficient, that data contextualization is kind of the major frontier, the major hurdle in front of us. How would you respond to this issue as a general conversation? Why is data contextualization so important for the democratization of smart manufacturing?
So, John, for a lot of reasons. The users of the data that comes from the manufacturing floor, the data that comes from warehouses, data that may come from the farm, these are all the things that are flowing in from sensors at the moment. And the people who can get the most value from that data usually know very little about how that data was acquired and actually may know nothing about how that data, what that data really measures or what it means. And putting context around data from sensors is vital for people to be able to understand what it means and for people to be able to find the data and for people to be able to compare the data. So you used a really interesting term where you said it's kind of our third attempt or third generation at data contextualization. If you look at the sort of three waves, in the very early days of data contextualization, we were really focused on making sensor data at least understandable. So, in the very early days, contextualization meant, give a sensor a decent description, give it an engineering unit, give it some limits, give it a minimum range, a maximum range, and perhaps tell you what piece of equipment it was on. And that's important because if I know that something has a value of 37, and now it's 37.5, and now it's 36.5, all I know is the value is moving around. If I know that that value is the inside temperature of the freezer, then I can guess maybe it's a little high if it's measured in Fahrenheit, or definitely too high if it's measured in centigrade. So if I get more context around that, I can really start making a conclusion that says that temperature is too high or too low. The sort of second generation moved that towards saying, what can I deduce about that temperature that will tell me about the piece of equipment? So can I deduce from that temperature if the refrigerator is or the freezer is well sealed? And can I deduce maybe if the freezer is going to fail or not? In today's world, you really want context that tells me where is that freezer, what's it doing, what does it feed, what's inside it. And you want to be able to trace through the consequences of events. So if I see that for a 6-hour period, the freezer temperature was outside specification for the materials that happen to be in that freezer, then I can start making an intelligent decision that says, now how do I recall that? Because I know that 1/10 of those materials are now in trucks that have left the facility. 2/3 of that is in containing containers, and the remainder of it is still going through the packaging line. So that instant ability to be able to put context on that is not just about the sensor, but it moves the discussion towards what was the sensor measuring and how does that pertain to what the process was producing. It is just a great example of that kind of increasing richness of context that we've done. So, John, does that give a reasonable explanation?
Yeah, it does, Doug. I've seen too many times, I think, the notion that in an effort to create value on the part of an IT organization, enterprise IT organization, in an effort to create value, there are some basic assumptions about connecting to a bunch of plant floor data sources and bringing that data into a data lake and then reasoning around that data and coming up with great, compelling insights. But my experience tells me that generally hasn't worked out too well. Has that been your experience as well? And what role might context play in that scenario?
Great question, John. So, without wanting to be dismissive of the tremendous value of big data solutions and data lakes, etc., and the great progress that's happening in that area, data lakes themselves are not the solution to the problem. They're just part of the solution to the problem. Structure of data comes from the physical world. The relationship between sensors and equipment is a physical relationship that needs to be recorded and tracked and mapped, and it's relevant to everything that tries to process that data, whether I'm trying to do something as simple as an OEE calculation or whether I'm trying to look at machine yield. Those relationships are critical, and you really only ever want to create that relationship once. But then the relationships exist between the pieces of machinery and between the materials that they can process and relationships with the schedules that they're trying to run. I think we'll talk a little bit later about the critical nature of what we are increasingly thinking of as a common data model. What we see happening with so many of the data lake projects is that context that actually exists in a lot of those systems, of the underlying source systems, actually gets stripped away as the data is making its way into the data lake, and then people try to recreate the context later, and they actually end up with a net context loss when moving into a pure data lake environment. So, what we see as critically important is to pick up as much context as quickly as possible and to then formally begin decorating context with more and more richness over a period of time. And that's a constant and it's a cumulative process for each of your smart manufacturing challenges that you attack, so that your data model and your context gets richer and richer over time. When you see it as a one-off data science project, which is what so often happens in the alternative environment, the context becomes transient and it's lost from project to project. So I would say the 80 to 90 percentile of the customers we're talking to have really found their experiences with major data science-centric data lake projects to be less than ideal, and the results somewhat underwhelming.
Lots to dig into there, but for the sake of the conversation here, let's move on to the second topic we had planned to discuss. I would say that of a handful of really important issues facing us as we drive the democratization of smart manufacturing is this notion of complexity, right? That unless we can work together to dramatically reduce the complexity, which clearly has direct connection to cost, not only will we prevent or continue to prevent small and medium manufacturers from engaging with us in this domain, we'll also make it difficult or continue to make it difficult for the entire enterprise IT community who struggles as it is with the complexities and the disparate nature of the way manufacturing systems spew data and make data available in completely non-standard and many ways complex ways. So if you can talk briefly to that, and then let's quickly move on to the third part of this conversation around how that pertains to the supply chain.
John, both you and I have been in this field for a long time. And, it was acceptable in my mind 25 years ago that it was hard to get connected to thousands of sensors on a process floor. The sensors came from many different vendors. They came through lots of different systems, and it was understandable that it was a relatively complicated thing to do. What's much more difficult to understand is how challenging it still is 25 years later. Getting to the individual sensor data has become easier, but all of the systems that have been created by these very proprietary vendor systems that contain the context information, that contain the data models that we've been talking about, is just as inaccessible as it ever was before, maybe more so. And the engineering effort gets repeated from system to system. So, if I'm going in and I'm trying to do a simple thing like an asset management system, I put in the same definitions about the equipment that I put in if I'm trying to do an uptime, downtime tracking system, and the same definitions that I put in if I'm trying to do, an equipment availability application, or the work just gets repeated again and again and again, surprisingly. So I know that if you'd asked me 20 years ago, would it still be this hard to be able to make sense of sensor data in 20 years' time? I would have said no. We would have made it vastly simpler by that point in time. So what it points to, and what I find so exciting about what you and your team are driving with the credibility of a public-private partnership, is the critical notion of true openness. Complexity will only go away when systems become truly open. And, as we heard in the previous session, is, even on simple things like communication protocols, there still are arguments around the pros and cons. Who cares? What I care about is, can I get the information model out? Can I exchange the information model between systems? And shouldn't it just flow automatically between the systems? So really making that stuff disappear into the background is the essential challenge that we face at the moment. And I think the work that we're doing collectively together, and the other vendors who are part of the Smart Manufacturing Innovation Platform, is really chipping away in a very meaningful way at that complexity, embracing some of the most modern techniques that are being driven by organizations like Facebook and Microsoft and IBM, and bringing that thinking of modern computer science to bear on industrial data is transformative. And honestly, John, the conversations are transformative. You've put vendors in the same room as us that we probably couldn't have had a civil conversation with. But when you've got CESMII forcing the conversation to occur, challenging us to be more open, and challenging us how to work together collaboratively, that really is having a profound impact, and I think is really contributing to that driving out of complexity.
We did the math recently, Doug, that tells us there are roughly 1 million IT developers, analysts, practitioners in manufacturing companies in the U.S., most of which cannot get involved in, or are prevented from getting involved in this domain because of that legacy of complexity. And so I think this is so important, both as you mentioned, the computer science ideas and the notion of class definitions and harmonized information models, but also this notion of crowdsourcing and creating an opportunity for domain experts to do something, to create an information model well once, put it in a marketplace, and allow others to either refine it, use it as is if that's acceptable, and get the community involved in evolving these things. They don't have to start as a 2-year standards body initiative. They don't have to start with a group. It can be a single domain expert that understands where to start, and we can then take that and turn that into something that 1,000 other manufacturers can use for their purposes. And the beautiful thing is, if I'm this small manufacturing company in the middle of Medina, Ohio, that we just saw the demo with, the DIY demo with, if they produce a smart manufacturing profile for a waste scale there, together with their partner Flexware, that profile could be used by Procter & Gamble and ConAgra and Corning and any other manufacturing company, big or small on the planet. Where in the history of this domain have we seen that kind of interoperability, that kind of reuse of material or domain expertise in this smart manufacturing world? So I'm particularly excited about this concept, and yeah, we're still early days here, but what you saw in this demo just now and what Doug and I are talking about is real. So Doug, we're almost out of time. Talk to me a little bit about how these concepts apply to the supply chain. We've talked about the four walls of the plant. That's been the the domain of much of the smart manufacturing ecosystem, the enterprise, but all within inside the firewall. Now we're talking about the supply chain. What are these capabilities? This idea of democratizing smart manufacturing. How does that even apply to the supply chain?
So, John, I think one of the huge shifts that's happened as a result of the COVID pandemic has been this growing awareness of the fragility of supply chains. And when we talk about manufacturing is one element of the supply chain. And when we look at the products that our customers make, when you're making a product that begins on the farm, has multiple factories involved, multiple areas of storage, multiple areas of distribution, being able to orchestrate that all together as an intelligent supply chain is fundamentally important. And it's the conversation, the real business value that so many of our customers are talking to us about now is around the need to help make supply chains more resilient. And the very techniques that we've been talking about to make factories more automated and more transparent are equally applicable across the supply chain. And we're really seeing that so much with our joint project around the National Supply Chain Data Exchange Project.
Yeah, in fact, let me, I know we've got too many slides here to really focus on, but let me share with our audience here, let me share a brief synopsis of this really, really crucial effort. Last spring when COVID hit, we here at CESMII got together with a handful of our strategic manufacturing partners and said, what can CESMII do in this domain of smart manufacturing? What can we do to help in the short term, but specifically as we think about coming out of COVID and dealing with the issues that Doug just talked about in terms of resilience, in terms of ensuring that we have the intelligence, the real-time insights, the ability to predict disruptions of this scale or of a more typical kind of a disruption, many of which still represent significant challenges to the manufacturing community. And so there was a unanimous call for this notion of the interoperability and the exchange of real-time data between manufacturing suppliers and their manufacturing customers. And so we put together a significant proposal with these manufacturing organizations to take these concepts, the Smart Manufacturing Innovation Platform, this notion of standardized information models, and deploy them in a supply chain setting. Obviously, with some new capabilities or some requirements that make these technologies secure and scalable in a supply chain architecture. But the bottom line was to connect several of these great manufacturing companies with their suppliers and build these capabilities out for them in a way that we can demonstrate to the world in a functional environment what the value is of having real-time data interchange and data connectivity with manufacturing operations from all of my key strategic suppliers. Doug, do you want to comment a little bit on this? I think this is such a critical set of capabilities. The industry has been working on different types of solutions in the space, but they're largely costly, monolithic, and complex systems that most tier suppliers will never afford. And so this notion, again, of a de facto standard for how these systems might interoperate together and coexist for multiple clients, this is a game changer, isn't it?
Oh, John, this is hugely important, vitally important. Not only are the world's biggest manufacturers recognizing that, moving towards supply chain autonomy is a vital thing that they need to do, every participant, every small to medium business that's in those supply chains needs to be empowered to be able to provide information, not only about what is it that I'm contractually obligated to deliver to you, but do I understand the specifications? Can I prove compliance? can I give you the provenance about the materials that I'm providing you? And can I give you enough insight into my manufacturing operations that the next step in the supply chain gets good warning ahead of any kind of disruption or holdup or delay that's going to occur in that, so that the supply chain as a network, so the supply network, can then intelligently respond to those disruptions. This is profound. And I think that the timing is incredible. And the fact that there are now multiple institutes, this is not just CESMII, but it also includes both Nimble and CESMII collaborating with the federal government and major vendors and innovative vendors like ourselves to actually tackle this problem. You know, I think you and I will be sitting back in a few years' time and saying that was a transformative moment for the industry. And I also do suspect that both you and I are going to have our first Thanksgivings ever where people are going to want to talk about supply chains, which, you know, I think just tells you how the nature of the conversation has changed. So, John, this is big.
Well said, Doug. And with that, I think we need to conclude both this conversation and the event for the day. Doug, thank you. I appreciate your thoughtful approach to this conversation, and I appreciate your time today. So with that, to the entire audience today, thank you.